Hi, it's Mike. Welcome to the shop. And this is a sort of a follow-up to my review of the Precision Matthews PM1440BV lathe, which is by far my most watched video on YouTube. And one of the things I commented on in the original review years ago, it's been, I don't know, 7-8 years, at least 6. Anyway, is because this uses a VFD and a variable speed, it does not have a mechanical brake. And I know you can't see it, but it does have a brake pedal, and all it does is hit a micro switch that shuts off the VFD. So I don't know, a couple years ago, yeah, it had to be 2020, I was looking at the parts diagrams for the gearhead version of the same lathe, which is the, I don't know, whatever, it's 1440 something. It's not the BV, it's just the regular gearhead. But it looks like still looks like, that the brake assembly inside the headstock is the same. So I wrote down all the part numbers. I emailed Precision Matthews and I said, hey, this is what I want to do. Can I buy the brake parts? And they're like, yeah, nobody's ever done this. We don't have any idea if it's going to work. Let us check with the factory. And they did, and the factory said, yeah, this should work. So I was like, okay, I ordered everything. It wasn't horrible. It was, I don't know, 75 bucks, but then $60 to FedEx it from Shanghai. Anyway, it all came a couple days ago. I have not taken it apart. I have not tried to put it on. There is one little 8mm pin that goes through the actuator rod and this thing. I'll show you. Anyway, I knew that was going to be too short, so I made one of those. And I mean, it's just a pin. No big deal. But we're going to see if that'll all work. I looked up the part number on the brake shoes. They were the most expensive part. They were $50 for the set. Yeah, it's a super common part number for these little Chinese drum brakes. I use them on mini bikes and stuff. And they're like 10 bucks on Amazon and $1 from AliExpress. Of course, it costs you more than 10 bucks to get them here. But anyway, so those were probably overpriced. But overall, I'm still not unhappy, because if I can add a brake to this and the total cost was 150 bucks, I'm all in. Anyway, let me show you, let me move the camera, I'll show you the parts, and then we'll take, oh, one thing I want to do first, and let me get my phone, is I want to get the stopwatch here. I want to see, we're going to spin the lathe up to 1,000 RPM and see how long it takes to slow down with the electronic brake, and then we'll time it again after we're all done and see what the difference is. So a part of the motivation for this is, my head looks all crooked in the camera. Either way, it is crooked. They told me that when I was young and got no better. Anyway, part of the motivation for this is when I put a collet on there, because there's no, you've only got a high and a low gear ratio on here. There's no way to lock the spindle and really tighten a collet. And at the 5C, I can, just pull on the handle enough, but I recently bought an ER40 collet, which actually I'll do another video on. I have not taken it out of the box. I have not tried it because I knew this had to happen first, or some way of locking it. Be able to really tighten them. So we'll check that out and measure it and stuff. I also bought it from Precision Matthews, and all kudos to them. They were like super helpful with this. I'm no complaints. Anytime I've ever contacted them, they have been just above and beyond in terms of service. I had the quartz halogen light die on this. I emailed them just to ask what kind of lamp it was, because it didn't say in the manual. I was just going to order some. They sent me a couple for free. I have actually since then converted it to an LED bulb, which I don't know if you can see. But this is actually just a cheap IKEA lamp. And what I did is, this is a 24 volts DC. So I got a 24 volt RV LED lamp, and then just splice the wires into the existing power supply. So this is low voltage. It doesn't get hot. It doesn't get safe. And it's really bright, and it's a lot better than the original. So there's a handy upgrade. Cost, I think it cost me more for the light bulbs than it did for the IKEA arm, which was like $8 or something, cheap. Anyway, let's spin this up, time it, and then we'll get started. Okay, so it's right at 1,000 RPM, and I'm gonna hit start right as I step on the brake. It takes about took about 1.5 seconds, which is really not bad. But like I said, the big goal here is to be able to lock the spindle when I'm pulling on a collet chuck. So anyway, this is the box that came. So the reason for the big box is that they suggested I buy a new pulley because it has the brake drum in it. I did take the cover off of this and look at it. I didn't take it apart, but I did look at it, and it looks like the bearing retainer on the input is machined for the pins, and that it has the brake drum, but it was only 15 bucks. I'm like, you know, send me the pulley. So anyway, this was the brake shoes, which, you know, it says right on it somewhere, motorcycle brake shoe. The CG125 is the part number you care about if you're going to try this yourself. If you go on Amazon and search for that, they're $10 or $11, $12 cheap. And it's got the springs in it. So this is all the rest of the parts. There's not much here. So this is the really important bit. So this is the actuator arm. This will go into the part on the lathe. The brake shoes will sit here. This will go down to the foot pedal. So this is the pin I made. It's just like the original, except that it's, I don't know, 3 millimeters longer, because the original one was made for whatever the original strap thickness was. It's like 1.5 millimeters. I got some 12 gauge steel, so it wasn't quite long enough. So I just made a new pin, drilled it out. It's actually made out of drill rod, silver steel for the friends overseas. This is the other pin that screws in there. This is 8 millimeters. The brake shoes go on here. This threads into the part on the lathe. And obviously, I mean, none of this is hard to make. But not having the dimensions or a drawing makes it a little harder. And then they sent me, or I asked for, so here's the original pin. You can see it's just a pin. It's nothing to it. I got some snap rings that fit this. I ordered the 8 millimeter ones to fit this. They were only, 60 cents, but they didn't send them. That's all right. I got a box of them from Amazon, no problem. As I didn't have any metric ones. So this is the new input pulley. It's cast iron. I checked the shoes do fit in there nicely. It's yellow, white. I think the one on mine's blue. I don't even know because I haven't taken the cover off, but we'll find out. Anyway, that's all the parts. This is the box that came in. And it came FedEx. I don't know. It was pretty fast. It came in a few days once they shipped it. So not too bad overall. Anyway, let's get turned around. I'm going to unplug the lathe and we'll get started. Okay, I have moved the toolbox and the little cart that's normally here. We found, I forgot all about this. So this wire, I didn't film this and you can't see it. So last summer I was working on a long piece using the DRO and the dimensions kept moving. Finally determined that the magnetic or the optical scale had failed. I mean, it would work, but it wouldn't repeat. So I replaced it with a magnetic scale. And anyway, I trimmed the lead and I rewired it. They sold adapters. I got it from Drill Pros, awesome people to deal with as well. But I liked the original readout, the Eason readout. So this has now got Drill Pro magnetic scales on it, which is, especially on the cross slide, it's really nice because I get 5 times the resolution I had before. And anyway, this was the extra cable. I forgot it was down there. So, little wire. Anyway, this has been unplugged. And I just learned something I didn't know before. When I shut the power off, this has always kept the fan running, cooling fan on the motor running for, I don't know, 5 or 6 seconds. to make sure the motor cools. Well, it turns out I shut the power off and I unplugged it and the motor was still running. So there's got to be some pretty hefty capacitors in that power supply. And that motor must be DC because it kept running with no power connected. So, okay, mine's not blue, it's black. Anyway, the brake mounts inside of here on this, you'll see it, we'll take it apart, hopefully anyway. The input shaft to the lathe is here. We got a hole down here where the rod's gonna go. I have not taken it apart yet. I gotta get the belt loosened up and taken off, which is probably the worst part of this whole job. Moving this motor around to adjust the belt has sucked 100% of the time since I bought the lathe. So let me find a wrench, and it looks like it's, I don't know, maybe 16 millimeter, 15. So one of the questions we got to figure out is what it's going to take to connect this to that. I'm going to guess that we can use this existing pin that's got the spring on it, because when you step on the rod, it goes the right direction. So I think that'll be okay. We'll have to take it out and see. Have to get that spring off of there without dying. And that's about it. Haven't had it off, so there's some nice chips under there. Anyway, I'm going to loosen up the motor. I'm going to shut the camera off. I'll bring you back when that's done, because that's just a pain in the butt job. Anyway, we got the belts off. Now hopefully this pulley will come off without too much drama. I have a puller. I haven't used. I bought this puller, I don't know, to have for a motorcycle project, and haven't actually used it. So anyway, I got this in low gear so we can hold the chuck and hopefully have enough advantage. I have not tried to take this out. Oh, that's not even tight. There's a surprise. I was expecting it to be pretty snug, but it wasn't. And so, now, yeah, that part isn't going to be as easy. So this is it's a posi-lock puller, because it's been a long time since I've had to actually need a puller for anything. And don't have one. Last time I needed one, I made something. So hopefully this will go big enough. It looks like it will. So I was saying, even though this is tapered and it's got a center drill in here, and it probably wouldn't damage the threads. This way, there's zero chance that it will damage the threads, assuming this is small enough to fit in the shaft, which it looks like it is. Wait, is this just sliding off? I didn't want to slide off with the, oh, there it goes. Now it's like, no. It looks like it's small enough. Let me, I don't know what size that is, maybe 3/4. That's it, yeah. All right, let's see how stubborn this thing's gonna be. Oh, it's moving. It's not too bad. It's definitely tight. Get our little stool out of the way. All right, well, our little puller is doing its little job. Excellent. Okay, so now let's see if this is the same as the new one. And so let me move the camera. Okay, so here's the one we just took off. Here's the original. They look the same. And clearly the OD is the same. Thickness is the same. You know, I haven't measured that, but I'm going to go with those are the same. So this is, it's 110 millimeter, 109.75, and 110.5. Yep. So those are the same. So for anyone that wants to undertake this for yourself, yeah, no need to buy an extra pulley. It's the same part, other than this one's painted black and this one's painted white. I don't think there's any real wear on the grooves, so there's really no reason to replace this. I will clean this before I put it on. So now, comes the interesting bit. So we got these two parts. So this is threaded, and I'm sure that this is, yeah, it's M12. So that goes there, and then this part is going to go in here, like so. Right, and is that all in camera? Am I zoomed in too much? No, that's in. Good. So our actuator is going to go down here through the hole, and then this will sit here. Let's see, the brake shoe's going to be like this. Yeah, that should work. That should work. So the key is, this has got a snap ring groove on the back, and there's one in here. The question is, how painful is it going to be to get this out of the lathe? That is the question. Hopefully not too bad. So we're going to wipe this down a little bit just to keep any crud from going in, hopefully, or limit the crud going in. Does this key come out easily? Yes, it does. We will put that aside so we don't lose it. So I really don't want to have to make a new one. All right, those are like 5 millimeter. This is 5, or are they 4? They're 4. Okay. See how it's not too bad. It's not bad. I hope this thing is not horrible. Whoa, we're losing oil. Okay, well, crapola, we got to drain the oil. It should be pretty clear. I haven't done this before. All right, let's put this in so we don't lose any more oil. And obviously, if I was to take that off, we'd have a real mess. So, one of the lousiest things on this lathe is taking the oil out of the headstock. I think I showed this in the original video. If I didn't, I talked about it. It's awful. And they know it is because they tell you a really shitty way to do it in the manual. So this is the drain plug. So really, the best thing to do is make a little trough and just hold it up there and drain the oil. So I'll loosen up the banjo, drop the gears out of the way. I'll go find something to put the oil in. I'll be back. This is different than how I've done it before. I think before, I mean, I did do it, but I've done it a few times, but I think I stuffed a piece of hose in there or held something. So this time I've got some heavy brown paper and I've got some aluminum tape, which is really sticky. So I took the clamp off so these wires can get out of the way a little bit. And I cleaned all this with isopropyl alcohol a couple times, so it should be pretty clean. So I think what I'm gonna, and I dropped the banjo obviously, so I think I'm gonna try to do is, you know, make a little funnel out of this paper and tape it on here and see how good that works. It may not work well. So let's put a little V in here. All right, and then kind of overlap this, and maybe this will work okay. Maybe not. I don't know. We'll find out. I think I'm going to make that a little bigger. Okay, so that looks okay. So I'm going to put some tape on here, and let's see what happens. Where's my tape? Oh, here it is. We can get the backing off, which is, Scriber works good for that. So getting the backing off of this stuff is kind of a pain in the butt. So, let's see here, because there's a little hole down there. We want to avoid that. Alright, I'm just going to fold a tab on the top of that to help remove it. Okay. Another little piece. Okay. And let's put this guy right here. And we'll pull that, and then we'll put one across there to seal it, which of course it's not really going to seal. That ought to do it. This is easier to peel than the other stuff I have downstairs. That stuff's awful. Okay, so we're going to put a little one right here. So hopefully that is pretty well sealed. I don't know if that shows up. How good? Yeah, it does. So we'll put a crease down here. All right. So our oil should flow down here and then into some form of receptacle, which I have not found yet. A plastic bucket. So hopefully the oil will flow down there. We'll hold it. This is actually clean, so I might be able to reuse it. This oil's not very old. Probably pretty clean, although it wouldn't hurt to change it. So that looks like about a 6mm, maybe. Let's see. Nope, it's bigger. Maybe an 8. Okay. Oh. That's snug. Get in there. Okay. Here we go. That oil's clean. Clean, clean, clean. It hadn't been that long since I changed it. It's not spotless, but it ain't bad either. Okay. And that worked really well. I got no oil on the machine so far, as long as I don't knock this on the ground. And this heavy brown, it's basically like butcher paper. That's working really well. All right, we aren't gonna sit here all day, but we'll get it to where it just starts to dripping. Okay, so I think we're good. I mean, still a little bit coming out, but I'm gonna move this before I knock it over and make a horrible mess that doesn't need to be made. So, with any luck, we'll peel this off and have little or no oil on the machine. Well, other than enough to just wet my finger, that is by far the best this has ever turned out. So, there you go. If you need to change the oil on these, which if you own one, you do, a little bit of aluminum tape and some heavy brown paper, couldn't ask for a better result. All right, let's see about getting this off. I hope that this isn't too hard to get out. I really don't know. Okay, so this bolt's longer than the bottom one, or it's just got smuts on it. Nope, it's got, had silicone or some kind of sealant on it so that it wouldn't leak oil. So we'll probably put some sealer on these when we put them back in. Keep oil from creeping out too bad. Okay. Okay, now we gotta grab the flashlight. So there's no pins that I can see. I was hoping maybe these holes were threaded and I could use them as jack screws, but that is not the case. I mean, this one is. I could probably screw a 12mm bolt in there and persuade it, but I'd rather not. Let me find something to tap on that with where I won't damage it. All right, I don't know how good this is going to work. I got a little piece of copper. We can just... It moved. Oh, yes! All right, well, got a little oil. So I'm just gonna put this rag under here for now because I'm hoping this won't take very long. Yeah, nice. So all this piece has is a cork gasket and a seal, which obviously the seal's working good because it hasn't leaked. So I'm just going to leave this towel down here. And what we've got to do is, it goes in this one here. I've got to take this gasket off without hopefully damaging it. Looks like it'll peel off with relative ease. It is. Because I can make a new one, but I don't want to have to. Oh, good. So we'll just put that in there, put the snap ring on it, and then we'll put this back together. Let me, oh, it had some silicone on here. So let me figure this out, how to seal it.